Hello and welcome to this Python tutorial. So in the last section of the course, we trained our artificial neural network twice, and we noticed that the second time we obtained a lower accuracy both on the training set and the test set than the first time. And so that introduces us to the bias variance trade-off. The bias variance trade-off is the fact that we're trying to train a model that will not only be accurate, but also that should not have too much variance of accuracy when we train it several times. And what happened for our artificial neural network? Well, we trained it twice, and we obtained two different accuracies, 86% first and then 84%. And so now we're not very sure which one of these two accuracies we should take to evaluate our model's performance. And so we need to optimize our way to evaluate our models. Because so far, what we did is split our dataset between a training set and a test set. And we trained our model on the training set and we tested its performance on the test set. That's a correct way of evaluating the model performance, but that's not the best one because we actually have the variance problem. The variance problem can be explained by the fact that when we get the accuracy on the test set, well, if we run the model again and test again its performance on another test set, well, we can get a very different accuracy. So judging our model performance only on one accuracy on one test set is actually not super relevant. That's not the most relevant way to evaluate the model performance. And so there is this technique called k-fold cross-validation that improves this a lot, because that will fix this variance problem. And how will it fix it? It will fix it by splitting the training set into 10 folds when k equals 10, and most of the time k equals 10. And we train our model on 9 folds, and we test it on the last remaining fold. And since with 10 folds we can make 10 different combinations of 9 folds to train the model and 1 fold to test it, that means that we can train the model and test the model on 10 combinations of training and test sets. And that will already give us a much better idea of the model performance, because what we can do afterwards is take an average of the different accuracies of the 10 evaluations and also compute the standard deviation to have a look at the variance. So eventually, our analysis will be much more relevant. And besides, we'll know in which of these 4 categories we'll be, because if we get a good accuracy and a small variance, we'll be on the lower left one. If we get a large accuracy and a high variance, we will be on the lower right one. If we get a small accuracy and a low variance, we will be on the upper left one. And eventually, if we get a low accuracy and a high variance, we will be on the upper right one. So this k-fold cross-validation is very useful, and besides, our performance analysis is much more relevant. Alright, so let's implement here k-fold cross-validation. So as you saw, I just restarted my kernel because actually when we run k-fold cross-validation, well, we don't need to re-execute this part because actually we will include this part in k-fold cross-validation. However, we do need to run the data preprocessing phase because of course we need to import the dataset and preprocess it since it will be part of the multiple training in k-fold cross-validation. So we just need to re-execute the code for part 1 data preprocessing. So here we go. Now the data preprocessing is done and we are ready to implement k-fold cross-validation and get a much more relevant accuracy on the test set. Alright, so here we go. Let's implement k-fold cross-validation. So what do we start with? Well, the tricky thing is that here we implemented a model with Keras, and the k-fold cross-validation function that we'll use belongs to scikit-learn. And therefore we need to, in some way, combine Keras and scikit-learn together. And there is the perfect module for it, and that belongs to Keras. It's a Keras wrapper that will wrap k-fold cross-validation by scikit-learn into the Keras model. So in other words, we will be able to include k-fold cross-validation in our Keras classifier. So the first thing that we need to do is to import all these tools, that is the wrapper and the cross-validation function by scikit-learn, that we will then combine. So here we go, let's start with the Keras wrapper. So this Keras wrapper is called Keras classifier. So we're going to start here with import Keras classifier. And this Keras classifier wrapper is taken from keras.wrappers.scikit-learn. Here we go, that's the Keras classifier wrapper. So let's try to import it and see if that works. Here we go, that works, and we are already using TensorFlow backend. Great. Now, the second thing we need is, of course, the k-fold cross-validation function from scikit-learn. And so from scikit-learn, and now we need to go to the module that contains this function, which is model selection, we import this cross-validation function that is called cross-val_score. So cross-val_score. All right, let's try to import that as well. Here we go, well imported, perfect. So now we have all the tools we need, and so basically we're ready to start implementing k-fold cross-validation inside Keras. And to do this, we're going to use a function, because the Keras classifier that we imported here expects for one of its arguments a function. It's actually its first argument, we will see, called build_fn, build function. And this function is simply a function that returns the classifier that we made here with all this architecture. So basically, this function just builds the architecture of our artificial neural network. So here we go, let's start making this function. And to define a function in Python, we start with def for define, and then we give a name to this function, and so we're going to call it build_classifier and parenthesis, and then column, and now by pressing enter we go inside the function, and that's where we define what the function will do. Okay, so now basically, as I told you, this function builds the artificial neural network classifier, and it will build it exactly as we built it here in this section when making the ANN. So basically what we only need to do is take all the lines of code here that builds the artificial neural network, but only the part of code that builds the architecture, not this fitting part here that trains it with the training set. So what we only need to take is everything from this last line of code to the beginning. Here we go, I'm copying this, and I'm going to put that in my build classifier function. So paste, and now we need to do a little bit of cleaning. So first let's remove the comment. We don't need them, it was just to explain this. Then let's take care of the indentation, like this. Then remove this comment again. All right, indentation, comment, indentation. Here we go, almost ready. Compiling the ANN, removing the comment, and indentation, perfect. Now we built our classifier, but inside this build classifier function. Okay, so the function is almost ready, but that's not over. This function returns something, and this something is the classifier. So here we just need to add, in the end, return classifier. All right, so now not only this function builds the classifier with the same architecture as we used before, but also it returns it. And now the function is ready. We can move on to the next step, which is to wrap the whole thing. Okay, so now what we're going to do is create a new classifier that will be the global classifier variable, because the classifier that we define here is a local variable because it is a variable inside the function. So this variable will only be created inside the function when we execute this code here that defines the function. Then, as soon as the function is defined and we execute the next line of code, well, the local classifier variable will no longer exist. And so now what we can do is create a new classifier that we're going to also call classifier. And this classifier will be the same classifier as we built here, but this will not be trained on the whole training set composed of X-train and Y-train. It will be built through k-fold cross-validation on 10 different training folds, and by each time measuring the model performance on one test fold. So the only thing that is different between this classifier and the one above that we built in the previous section is only in the training part. All right, so let's do it. Let's build this new classifier trained with k-fold cross-validation. So classifier equals, and now that's where we're going to use the Keras classifier, the wrapper of k-fold cross-validation. So we take our Keras classifier, which by the way is a class. So right now we're creating an object of the Keras classifier class, and inside this class we're going to input the arguments. Okay, so the first argument is, as I mentioned, this function, the build classifier function that builds the architecture of our artificial neural network. And so the name of this argument is build_fn, and so this will be equal to our build classifier function. So I'm copying this, here we go, and I'm putting that as input for our build_fn argument. and this should be input this way, not inside quotes. Alright then, next argument. The next argument is the batch size, because indeed, so far we just built our artificial neural network and we included this code in the build classifier function, but remember, we didn't include this part of code that does the training. And in this part of code, as you notice, there is the batch size and the number of epoch. So that's all we need to add to specify on how many epochs we want to train our artificial neural network and with which batch size. So here we go. Let's add these informations here. And by the way, the name of the two arguments we need to input here are the exact same names as the two arguments here. So we just need to copy them, copy, and add them here. All right, and now we have everything we need. We have the function that builds the architecture of the ANN, and we have the two important informations for the training, that is the number of epoch and the batch size. Okay, but now k-fold cross-validation is still not applied. And that's where we use scikit-learn, and more precisely the cross-val score function by the scikit-learn model selection module. So next line of code, and let's input that. So as you understood, the use of k-fold cross-validation is to return a relevant measure of the accuracy of our artificial neural network on the test set, and therefore the cross-val score function will return the 10 accuracies of the 10 test folds that occur in k-fold cross-validation. And therefore what we need to start with when using the cross-val score function is to create a new variable that we're going to call accuracies, and that will contain the 10 accuracies returned by k-fold cross-validation with k equals 10. And so here we'll add equals. We're going to use the cross-val score function. Here we go. Cross-val score, and in parentheses we need to input the several arguments. So let's inspect this function to see the arguments that we need to input. Here they are, parameters, and here we go. The first argument is estimator. And so what is it? That's the object to use to fit the data. So can you guess what it is? Well, that's of course our classifier that we just built here with Keras classifier. So that's exactly our estimator, and therefore we need to add here estimator equals classifier. Perfect. Then next argument. The next parameter is x, and that is the data to fit. So basically that's the training set. The training set from which we're going to create 10 train test folds on which is going to be applied k-fold cross-validation. And x is the matrix of features part of the training set, and therefore x is of course xtrain. Great. Now the next argument is y, and y is the target variable of this same training set, and that's of course y equals ytrain, because of course to train a classification model like artificial neural network, we need both xtrain and ytrain to understand the correlations. Alright, and now another very important parameter that we will see below, here it is, that's CV. And CV is basically the number of folds of train test folds you want to create when applying k-fold cross-validation. And so that choice is pretty arbitrary, but most of the time 10 folds are used for the simple reason that we will get a relevant idea of the accuracy if we have 10 accuracies. With 10 accuracies, we will clearly see if we have good accuracy, that is if we have low bias, and if we don't have too much variance, which is what we want. So let's pick CV equals 10, and I recommend this number most of the time. Alright, so we could stop here, but actually there is one last argument that we need to input, and that is very important when applying k-fold cross-validation for deep learning. This argument, this last parameter, is njobs. Okay, so njobs is the number of CPUs to use to do the computation, and -1 means all CPUs. So why is this an important parameter? Well, that's because basically the artificial neural network that we trained in the previous section is this time actually going to be trained 10 times, because it's going to be trained on 10 train folds. And you remember how it took time to train the model on one training fold? That was, by the way, the whole training set. So imagine how much time it will take if we train it on 10 train folds. And so of course we want our computations to go faster. And that's by using the njobs parameter and setting it to -1 to use all the CPUs, and therefore what it will do is run parallel computations to get this done faster. So we will not see one training fold one at a time, we will see the different trainings on the different train folds run at the same time. So that's a very important argument. And here we'll add njobs equals -1. Perfect. And that was the last argument we needed to input in this cross-val score function. So basically now we are ready to run k-fold cross-validation. So that's what we're going to do right now. Remember, we're doing this to check two things. First, if the real relevance accuracy is closer to the first one we obtained, that is rather 86%, or the second one we obtained, that is rather 84%. And then the second thing we want to check is where we are in the bias variance trade-off. And so we need to check that we have a low bias and a low variance, that is high accuracies and small differences, small variance between these accuracies that we're about to get. All right, so there we go. We are ready to execute this. However, remember, since I reset everything by restarting my kernel, we need to also import the Keras libraries, because as you can see, we use them in this k-fold cross-validation code. And actually, I think it might be easier for you to have them already in the code here, in case you are using k-fold cross-validation directly. Okay, so here we go. We're going to execute this. So it's going to take a while because our artificial neural network is going to be trained 10 times on the 10 train fold, and each time we're going to measure the accuracy on the test fold, and that's how we're going to get 10 accuracies. So let's do it. We just need to actually select all these lines because we already executed this. And now let's press Command and Control plus Enter to execute. Here we go. It's on. It's live. So as you can see, there are parallel computations right now. We can see the same epoch running separately on different train folds. So that's exactly what I was telling you. That's parallel computation. So this is going to take a while. So I'm going to move forward to the future. So I'll see you very soon at the end of this k-fold cross-validation. All right, it's about to end. 98, 99. And here we go. That's over. K-fold cross-validation is over, and it seems that the accuracies are around 83%. Let's check it out right now. We're going to go to Variable Explorer to have a look at our vector of accuracies. Here it is, and indeed, the accuracies are around 83%, 84%. So that's exactly the accuracy we obtained the second time on the test set. So the 86% accuracy we obtained the first time was not relevant. So that's why I want you to be motivated to use k-fold cross-validation. It's to avoid that kind of trap. This is the relevant result of performance evaluation. And if you want to have one final result, well, the relevant accuracy would be to take the mean of all these accuracies. And of course, then we will compute the variance to see if we have high variance or low variance. So let's do it. We're going to compute the mean of these accuracies. So let's create a new variable mean equals, and to take the mean of this vector of accuracies, there is nothing more simple. We just need to take our vector, accuracies, and then add a dot, and then add the function mean with parentheses. And this will get you the mean. And let's also compute the variance. So we're going to call this variance as well, equals, then again we take our accuracies vector, then dot, and then to get the variance we use the function std with parentheses as well. So I'm going to select these two lines and execute. Here we go. We are about to get the mean, which is of course 83.4%. So that's what we said. That's definitely the relevant accuracy to evaluate our model's performance. And the variance is actually quite small, 0.9%. So that's less than 1%. And therefore we have rather low variance. So here we go. That's where we are in the bias variance trade-off. And now we have a challenge. Now that we know how to get the relevant accuracy for any deep learning model, well, we're going to take the challenge to beat this relevant accuracy. That means that we will try to make a better artificial neural network to get a higher accuracy than 83%. We will try to go up to 86%. That will be our challenge, and we will try to make it successful with parameter tuning. Until then, enjoy deep learning!